Okay, so today, for our discussion, we will look into uh, few concepts. Like, last time we looked into um, some interesting concepts with respect to ADSL, right? And we also saw 30 PCM concept. And students, can you tell me also what concepts we looked into? What was the points of discussion here in the last class?
So the MNP concept.
Very good, right? So that, do you think that was a very interesting concept, or like how is it, is it useful customer point of view, or how is it?
It actually gives a privilege to the customer, like depending upon their needs and necessity, they can change the network connections, like
Correct,
from one
right?
provider to another provider.
Yes. So that was the main, motto of having an MNP. And thereby, there was one more thing that just came up, whereby you can also have competition, isn't it? So that was important. Now, without competition, do you think anything is going to work out well? I don't think so, right? So that's actually necessary when we think of, improving the quality of the service. Right. So today I have chosen a few concepts on DC power supplies, UPS, and a few other things. So we'll just look into it. Now, I've just put up, these questions in the form of, marking, so that, you'll be able to, break up things and work it out. Fine. So we have a concept called open circuit output voltage, and we have something called short circuit output current, and also regulation. So can you tell me what is this open circuit and what is short circuit? I'm sure you would have come across these concepts, right? So can you tell me what these are? Open circuit, short circuit. Yeah, you can tell me in your own words. That's fine. Some answers. Waiting for your answers.
So something like at the output, rather than connecting a load resistance, you can just tap it out by connecting the two ends of the output wire. So that would
Very
give
good.
the
Very good.
voltage.
Yes. So that's an open circuit where I do not connect anything at the load side, and the reverse is closed. Right now, regulation. What is regulation? That's a very important concept, right? Regulation.
So to be able to control the output.
Very good. So is it really necessary to regulate things? Or it's fine if we don't regulate also? Remember, I was giving you some examples with regards to regulation, isn't it? So can you tell me what this regulation is talking to us about? Okay. So anything for that matter, right? We need some connection, right? Which actually works like a feedback. I think all of you are now, you have looked into the concepts of feedbacks, right? There's something called negative feedback. So negative feedback, what's happening? You can actually check, the kind of output that comes in, and based on that, you are deciding either to increase the value of resistance or to decrease the value of resistance or the capacitance. So you are kind of having a feedback there, right? So this regulation is needed in order to increase or decrease a certain amount of output levels. So now we will look into it, one by one, and we will try and see what this exactly means to us. Open circuit output voltage. Now in your interviews, they could ask, what is open circuit, what is closed circuit. You're an electronic student, right? So you should be able to differentiate, between what these are actually referring to, right? So open circuit voltage is the difference of electrical potential between two terminals of a device when connected from any circuit. There is no external load connected. Now, this concept is important. No external load connected, right? And no electric current flows between the terminals. Now, there's no load, and hence there is no flow of current. Simple, right? Now, short circuit. Short circuit becomes the opposite of this open circuit, where you have very low resistance connection between the two conductors. So it is just like, I think you have seen this fuse, right, in this MCB switches, where small thin wire actually connects. So usually, if something goes wrong, in the connections, the electrical connections. So this small wire that is there will be blown off, right? So thereby what is happening, it is trying to reduce the damage that is going to be caused by blowing of the fuse. So that's a small hair-like wire, right? So this short circuit is also having a small connection, right, between the two terminals. Now this terminal is with respect to the load we are discussing, is a low resistance connection between the two conductors supplying electrical power to any circuit. This causes excessive current flow in the power source to the short. So that's called a short, and may even cause power source to be destroyed, right? So if in case this fuse is not blown, right, then what is going to happen? It is going to destroy, whatever connections that are into it. Okay. And if a fuse is the supply circuit, it will do its job and blow out, opening the circuit and stopping the current flow. So this fuse, that you see, slightly gets connected, and since it's very thin, right? What will happen is it will break off, right? So since it's broken, there's no flow of current that happens between the two terminals, right? How many of you have seen the fuse? Have you seen it connected in the PCB, in the MCB? Yes,
Yes,
have
sir.
you
Like
seen
in
it? Yeah.
second semester, we had that lab.
Correct, correct. So during the labs, you've seen it, right? Yeah. Okay.
Yes, sir.
Good. So sometimes it's very good to see things practically and understand how these things are. So that that's the main idea of having practicals, isn't it? So you can actually see them, understand, you can perform experiments, and you can understand what's happening exactly. Right. So yeah, good. You guys have seen it, and it becomes easy for you to understand. Now, regulation. Now, regulation is something important where we maybe you can think of the fans regulator, right? So in this fans regulator, I can either increase the speed, decrease the speed. So it's like a control given to the user, isn't it? So if there is no regulation, okay, if the seller sells you telling please take this and use it at the same speed, you would have no control on the speed. Would you like to use it? I don't think so, right? So regulation is one such thing, which will actually help in understanding or controlling the speed, right? You would have seen this control of DC motor, and you know the speed control of your stepper motor, right? So here also there is a kind of regulation that happens, and when I say regulation, it means that it is referring to some kind of pulse that I'm going to give, and this pulse width will either increase or decrease, or change the way that you know the power is supplied, and whereby once the more power is supplied, then we can see that the speed of this motor gets increased. So it is just like a PWM, pulse width modulation, the concepts that we discussed previously. Now, this power supply regulation is the ability of power supply to maintain an output voltage within a specified tolerance as referenced to changing conditions of input voltage or load. So I am given the power, right? I am given the power to change to the specified tolerance, right? So once I have that power, so it makes life more comfortable, right? Okay. So the input voltage and load. So referencing to the changing conditions of input voltage or load. So how much ever current that flows through the load can be controlled, based on the type of input or the levels of input that you can give. So most electronic equipment is powered from DC voltage derived from unregulated AC main voltage. Now there is a concept called unregulated supply. Can you tell me what is this unregulated supply? Have you come across this term unregulated? Yeah, unregulated, regulated. Have you come across these concepts?
The output will vary, sir. Like
The output,
it doesn't have a constant value.
okay. And can you tell me more about it? Yeah, can you tell me more about it? Someone else can
Like
help
it
me
would
out.
have various noises
Yeah.
and stuff, sir, like ripples.
Okay.
So though we'll have like a particular voltage, but it won't be proper.
Okay. Yeah. So you can imagine of regulator, right? You can probably think of what a stabilizer, right? So once the supply comes through, it's actually not constant. So once it passes through the regulator, right, you will be able to find that the output from your potential or the potential difference that you can find after the stabilizer is going to be very stable. So hence the term, stabilizer, right? So, so many times, we need such things, right, where we need constant outputs, right? Because these nowadays, you find these electronic devices to be very sensitive. So if your powers are fluctuating, then it becomes difficult for the inbuilt circuitry to handle them. So instead, what we do in order to save, okay, these electronic gadgets or something, what we do is we try to use an external regulator, okay, that will be in the form of stabilizer, right? And of course, these stabilizers wouldn't be as costly as your electronic device, obviously, right? So it's a wise thing to invest in them and get a constant output. Fine. So most electronic equipment is powered from DC voltage derived from unregulated AC mains voltage. Rectifier circuit, okay, converts AC to DC. Now you would have seen this rectifiers, right? Where you should have seen half wave rectifiers and full wave rectifiers, right, with the help of diodes. Can you tell me an interesting property of a diode? What is a diode and how does it actually function? China, maybe you can answer that question. Come on, it's not a difficult question, is it? What's a diode? Krishnan? Okay, anybody, you can tell me what's a diode, of course. Yeah, yeah, I've got an answer. Says diodes are semiconducting device and
It's
current.
a semiconductor device with two terminal.
Okay. Yeah.
Hello.
Yeah.
Am I audible, sir?
Yes, yes, you are
Yes,
audible.
sir. It's a
Kind of.
semiconductor device with two terminals.
Okay. And then,
Current flow is basically only through one direction.
yes, that is a very important property in a diode, right? So there's something called forward bias and reverse bias, right? So when it's forward biased, that's when it starts conducting, and when it's reverse biased, it will stop. So utilizing the property of this, we can actually change the way how your circuit responds. So there are a lot of applications actually with regards to diodes. Okay, so these diodes are actually the main uh, part, okay, the main factor when we actually look for rectification. Because when you see that the waveform is going in its positive and coming down in its negative, so when it's in its negative side of the waveform, okay, that's when you find that just a moment. Right? So the diode has this special property, as I was mentioning, right? Where as soon as it gets its negative potential, it wouldn't stop. It would stop working, right? It wouldn't, function. So this is a very special property of a diode, and we are utilizing this property in many of the circuits, right? So regulation is one such thing where most of the circuits will actually have these diodes in them. Okay, fine. The other thing that we'll be looking into is UPS, right? So we will just see the stages in UPS and what does it involve. I think many of us would be very much aware as to what an UPS is, right? Uninterruptible power supply. So usually we use this when our power system fails, isn't it? So it has an instantaneous power with main utility power source. When the main utility power source fails, okay, it allows time for power to return. Okay, how does it do that? It has a battery, gets charged, and this battery is going to serve the purpose, right? So the main thing, as soon as the power goes down, maybe you're working on a desktop or something, right? So you have time to save your work and then probably shut it off, right? So these days, of course, we do not see much of desktops, except in the studios, uh, but most of them are right now into, you know, laptops which actually have better batteries. Okay, now, the UPS is not limited by equipment type, and it ensures uninterruptible power to computers, data centers. Now, data centers having power is really, very important, right? How is it important? Um, if it's just connected, okay, then we will have internet. If it's not connected, okay, the data centers are not connected, then it means we do not have a stable internet connection. Now, you can think of not having an internet these days, isn't it? So, that's a very essential part and parcel of our life. Now, the two essential stages that we can see in an UPS is rectifier, battery bank, inverter, and a filter. Now, rectifiers are used to regulate the supplies, right? Battery bank is used so that the charge is stored, and inverters are used so that as soon as there is a sense of zero, then immediately it turns on one, right? And then we use a proper filter. So these are the things, with regards to UPS and the essential stages of an UPS. So do you think these days UPS are very essential? Yes, no? Are they essential?
Yes, sir.
Okay. How are they essential?
Like
due to
during
frequent
summer
power
times,
cuts.
power cuts are mostly.
Mm. Yes. So usually, during summers we have this, load shedding concept, right? So during that time, it's actually going to help us, right? So probably in our upcoming sessions, we'll be looking into what an optical fiber is with, okay, what is the things involved in an optical fiber, right? For example, you can see it has an information source, encoder, transmitter, and we'll also be looking into a few more concepts of optical fibers, which has glass fiber and plastic fiber and all this stuff, and what are its properties, and probably we look into the acceptance angles, okay, and all those stuff, right?